So here is our next topic is adrenogenital syndrome. In this, it is also known as congenital adrenal hyperplasia. In this, the adrenal gland is hypertrophied hypertrophied or enlarged because continuous secretion by the ACTH stimulation. It does not produce any hormones because of deficiency of the enzyme which synthesize cortisol and aldosterone. Before continuing, we should first recall the hormone synthesis pathway. It, it is a brief overview. From cholesterol, basically we are discussing 3 enzyme deficiency: 17 alpha hydroxylase deficiency, 21 alpha hydroxylase deficiency, and 11 beta hydroxylase deficiency. From cholesterol, 17 alpha hydroxylase form dihydro. From cholesterol, 17 alpha hydroxylase form androgen. Androgen basically testosterone, dihydrotestosterone, and estriol. And from the same cholesterol, 21 alpha hydroxylase form deoxycorticosterone, and deoxycorticosterone act as a precursor, convert into by the help of alpha beta hydroxylase convert into aldosterone and cortisol. Here we have to see that if there is deficiency of alpha beta hydroxylase, then aldosterone and cortisol will be low, but the precursor of aldosterone, deoxycorticosterone, which is hydroxylized by 21 alpha hydroxylase, will be present. So there will be effects or symptoms of the aldosterone present, but there will be decreased cortisol levels. Now, if there is deficiency of 17 alpha hydroxylase, then androgens will be low. Then if there is deficiency of 21 alpha hydroxylase, aldosterone and cortisol will be low and androgens will be high because it is of independent pathway. And same with the alpha beta hydroxylase, aldosterone will be low, but precursor alpha deoxycorticosterone will be high, act as aldosterone, but androgen will be high because of the independent pathway. But here is interesting pathway is that in deficiency of 17 hydroxylase, aldosterone will be high and androgen will be low, but cortisol will be low. The question is why here aldosterone is high? Because the precursor progesterone, which is processed by 17 alpha hydroxylase, which is not processed by 17 alpha hydroxylase, is present and it converts into aldosterone, but 17 hydroxyprogesterone, which is processed by 17 hydroxylase enzyme, is low, and which form the cortisol. So deficiency of this 17 hydroxylase 17 H progesterone leads to decreased cortisol levels. So in 17 hydroxylase deficiency, there are two types: classical and non-classical. In classic, it is also known as salt wasting syndrome. There will be decreased aldosterone and decreased cortisol, but androgen will be increased. So decreased aldosterone will lead to hypotension and hyponatremia, and decreased aldosterone will also cause hyperkalemia due to sodium potassium pump. And in non-classic, aldosterone will be normal, cortisol will be low, and androgen will be high. The clinical feature of non-classic is ambiguous genitalia in female and precocious puberty. One thing here interesting is in androgens, female is the androgen is secreted by mainly adrenal glands, and in males it is because of testes. So in adrenal disease, female is more affected than male. In 17 hydroxylase deficiency, aldosterone is high, cortisol is decreased, and androgen also decreased. Clinical features: hypertension and hypokalemia due to increased aldosterone. It has two karyotypes, XY and XX. XY leads to male pseudo hermaphroditism, phenotypically male, phenotypically female, but no internal reproductive organs. XX karyotype, phenotypically female, but here is normal internal sex organs but lacks secondary sexual characteristics. Next is 11 beta hydroxylase deficiency. Here aldosterone is low, cortisol is low, and androgen is increased. Here clinical feature is hypertension due to 11-deoxycorticosterone and masculinization. Here aldosterone decreased but 11-deoxycorticosterone is increased.